All right, we're going to finish up chapter 2, and to do that, we're going to look at scientific notation. We've used it quite often already in class, and you've seen it in a lot of the problems, but I want to show you exactly how it's written, how you can write it in scientific notation, how you can write it in what they call standard formation if they do give it to you in scientific notation. And also, more importantly, how to type it into your calculator so that you can actually use it in calculations. So first, we have to define scientific notation. Numbers are written in the form of m times 10 to the n, where the factor m is a number greater than or equal to 1, but it's less than 10, and n is a whole number. So this m here is basically anywhere from 1 to 9, okay? Well, I guess 9.9999999. And n is not going to be a decimal at all. It's not going to be a fraction. It's going to be a whole number. It can be positive or negative, though, but it's going to be a whole number. So here we have 65,000, right? And what we want to do is we want to do the decimal, which is way here at the back, and move it over 1, 2, 3, 4 spots. So we have a whole number, your first number, then your decimal. Okay, so that's why it's 6.5 times 10 to the 4th. The reason it's 4th is because that's how many times I move it over. 1, 2, 3, 4. And you'll notice the only numbers here are sig figs. So the zeros in this original number are just placeholder zeros because there's no decimal point. So I read from right to left, and we start counting the first non-zero number, 1, 2. Those are my only two significant figures, so the only two that go into my scientific notation. Now, if we start with a decimal like we do here in B, we're going to take where the decimal is, wherever it is, and we're going to move it 1, 2, 3, 4 spots for this one to go between the first number and the rest of the numbers. So I moved it over 4 spots to the right, so that's why it's a -4. 1.2 are the only two significant figures, and notice it's a value between 1 and 9, one digit, then the decimal. Okay? Let's see what else we can learn about this. Steps to help you figure this out. A lot of people like to do step-by-step stuff. And if you don't know what it is, basically you're going to determine your big number, your m, by moving the decimal point to the original number to the right or left, so that only one non-zero digit remains. Only one. You can't have like 10.5 times 10 to the 5th. It's got to be 1.05 times 10 to the 6th. Determine n by counting the number of places you have moved. So n here is the number of places you have moved. Okay? If you move it to the left, it's positive. Left is positive. Move to the right, it's negative. Okay, negative is when it's going to be the standard number is a decimal, like a smaller number than 1. And positive n is going to be when it's a larger number than 1. Significant figures are only the ones that you use. So significant figures, if the value is already in scientific notation, the value of significant figures is the amount of numbers in m. So the only digits you see are significant figures. You're going to read it the same way you do any number that has a decimal point when you're counting significant figures. You just ignore the times 10 stuff. Okay? When you're putting any number in scientific notation, m must have the correct number of significant figures. Okay? Only sig figs are included, nothing else. No placeholder zeros in this. Now the big thing is your calculator. I know it doesn't seem that big, but it is. There's this button on your calculator, and it's EE. So right now, take out whatever calculator you normally use. Look for this EE button. You may also see it EXP, and some Casio calculators have one times 10 to the n. Now, for our TI ones, it's going to be above the 7. I know you can't see it because it's very dark in this one, but it's going to be above the 7. Sometimes it's the second function above the 7, so it's in little orange or yellow numbers. For Casio, the EXP is usually down in this area, down near the equal sign. And some other ones are down there near the equal sign. The EXP is down there. So take a look. If you can't find it, it's no big deal. See, here's the EXP. It's no big deal. I will show it to you when you come to class. So if I have 5.44, that's what this is, 5.44 times 10 to the 7th divided by 8.1 times 10 to the 4th equals. So they take you step by step as to exactly what you want to put in the calculator. Now this is the answer that comes out, and you can get it to come out in scientific notation, but You can also round it. You'll notice I have 3 significant figures here and 2 significant figures here. So my answer can only have 2 significant figures. Okay, so here, over on this side, they actually step you through. The ratio of grams to moles, if you have 5.44 times 10 to the 7th, that's going to be superscripted, grams for every 8.1 times 10 to the 4th moles. And then it shows you how to calculate it, how to put in your calculator. Do not type in times 10. Don't do it because it's just going to multiply everything by 10. You either are going to use the EE button or the EXT button, or my Casio people, there's a times 10 to the n button just for you. Depending on the type of calculator, it's going to be a little different, but I'll show you when you come in if you're not sure. When you write your answer, be sure to double check your significant figures. And don't forget your units, okay? And we'll go over it in class with your exact calculator. So bring your calculators to class. Don't just leave them at home. We want to make sure we can get this down so when you have a test or a quiz, you get it right. Now, the very last thing we're going to learn is something called directly and inversely proportional. Directly proportional is when you have two numbers whose quotient, remember a quotient is the answer when you divide, who has a constant value. Like density is one of the ones they use over here. If the mass goes up, the volume goes up, because it's always going to have the same value. As one increases, so does the other. One goes up, the other goes up. When values that are directly proportional to a graph, it makes a straight line. Right through the origin. Inversely, on the other hand, is when the product is constant. So as one value increases, the other has to decrease. When you think about it, you have 1 times 6 equals 6, right? Well, 2 times something equals 6. What's 2 times 3? And from 1 to 2, the number went up. From 6 to 3, the answer went down. It has to in order to keep the same product. So that's why when you multiply, they're inversely related. As one goes up, the other goes down. When they're inversely created, the graph is a curved, a parabola or a curved line is created. And that's it for chapter 2. So we'll finish this up. Remember, your test is coming up. Make sure you're ready, you study, and come in with any questions.